In this video, we're going to look at how to prove two triangles similar. In order to do this, the first step is when you look at your pairs to determine which of the three theorems you're going to attempt. Sometimes you can attempt more than one, sometimes you can just attempt one. So we'll get started by taking a look at these two triangles here. As you can see, the only information is given is angle measures. There's no information about any of the side lengths, so that's going to immediately kind of eliminate side, angle, side, and side, side, side. So we're going to focus on angle, angle. And in order to do that, I need to have two bubbles in my flowchart, and each one needs to have a pair of congruent angles. So I'm taking a look. Initially, we should see that A is 14 degrees and D is 14 degrees. So because of that, we can say that angle A is congruent to angle D, which means they have the same measure. And then when we look at this, at first glance, 89 does not match up with 77, but please don't assume that that means they are not similar. We have the ability to find angle C based on the triangle angle sum theorem. So we would first need to add up 14 and 89 and then subtract that from 180, and that will give us 77 degrees for C. So right here, angle C is going to be congruent to angle F. With this theorem, you can use either these two pairs. You could have also found angle E and used B and E. You get to choose. So these are our two facts. And again, please remember the whole point of this is to prove two triangles are similar. Because of this fact, we have proven that these two triangles are in fact similar, so I need to write my similarity statement. ABC, and just make sure when you're writing that second one it matches up. So A goes with D, B is going to go with E, and C is going to go with F. Taking a look at this one over here, we should see that we have two right triangles, so that's one pair of angles, and then I've got two pairs of side lengths. So I'm going to attempt for this one side, angle, side, again because I know two sides, 10 and 12, and one angle. So when I set this one up, I'm going to have a pair of sides, so I'm going to do 10 over 5, and that's going to reduce to 2, so that's one of my bubbles. That's my side. I also need an angle, so I've got, in the middle here, I've got angle H is congruent to angle K. I know those are congruent because they're both right angles. They're both 90 degrees. And then my third side is going to be 10 and 6. So 10 divided by 6 reduces to 2. So because these two equal the same thing, that means I have two pairs of proportional sides and an interior congruent angle. So my conclusion is that triangle GHI is similar to triangle JK. Oh, I put J twice. Whoops, JKJ. Well, that works. And then for these two, I have no information about the angle measure, so no way to find that out. So I can't use side, angle, side, or side, side, side. So I'm going to focus, I have no information about angle, so I can't use side, angle, side, or angle, angle. So I am going to attempt side, side, side. Now, it does kind of start to get difficult to determine how they've been rotated. Has this triangle been rotated around? Has there been a flip? So we are always going to correspond kind of our shorter sides together. So for example here, I'm going to do 2 is the shortest side on triangle MLN. So I'm going to say 2 corresponds to the shortest side over here, which is 1, and that's going to reduce to 2. So that's one of my side bubbles. The middle side here is 4, and 4 corresponds to 2 over here, so 4 divided by 2. So far, so good. And then my last one, 5 is my longest side divided by 3. And that does not reduce to 2. That reduces to 1.67, kind of repeating there. So because of this, my conclusion is that they are not similar. So please don't assume that just because I'm asking you to prove that they are similar, they will be similar. Please keep in mind that you actually have to go through the process. So just because this one I can use side, side, side doesn't mean it will work. It just means that that is something I need to test out and see if it will work. So these first two, I used angle, angle. These two, I used side, angle, side. Both of those checked out. This third one, however, I attempted to use side, 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 but it did not work, so my conclusion there is that it is not similar.